Okay, so this is summer 2011 paper and the variant is 43, and this question is from work, energy and power. And in mechanics it's really helpful if you draw a diagram. It makes solving the question afterwards like a lot easier. So that's what I'm going to do. So the question says a block is pulled for a distance of 50 meters along a horizontal floor. So it's like this. We have a floor and it's 50 meters in length and we have a block on it. Okay, and then it says that it's being pulled by a rope that is inclined at an angle of alpha to the floor. So you can draw the rope like this, being inclined to an angle of alpha to the floor, or you can draw it in a different manner like this. This is a block, okay, and you can draw your rope like this, and you can have a dotted line to show it as a reference to the horizontal floor, and you can have your angle alpha like this. So you can either draw like this or you can either draw like this. It doesn't really matter. So I'm gonna erase the second one. Okay, so now let's go on. And they say the tension in the rope is 180 newtons. So we know that this tension in this rope is 180 newtons, and the work done by the tension is 8200 joules, and they say we have to find this angle alpha. Okay, now let's see first what work is. Work done is basically force into distance, right? Over here in this particular question, they have given us the work, which is 8200 joules. The force is F, and the distance is 50 meters. So I just plugged in the values that they've already given. I have plugged in the value for this, which is work. I plugged in the value of distance, which is this. Now for the force. See, the force is acting at an angle, right? So this force is going to have two components. There's gonna be a horizontal component and a vertical component. So if I look at this one, this component, which is the vertical component, so it's gonna be, if I take this as F is equals to 180 Newton. So this vertical component is going to be F sine alpha, okay, and this horizontal component is going to be F cos alpha. And we're going to take the component of force, which is along the direction of motion. So since our block is moving in this motion, okay, forward, it's moving forward, so we're gonna take, our block is moving like this, forward, so we're gonna take this one, the horizontal component, not the vertical one. We're going to take the horizontal component, and that's going to be F cos alpha. Okay, now we're going to have F cos alpha is equals to 8200 divided by 50. Okay, and we take out the calculator and we so using the calculator we get to know that this is 164. Okay, so we were able to figure out that f cos alpha is equals to 164. And before this, in the question, they gave us that the tension in the rope is 180 newtons. So tension is also a force, so basically our force is 180 newtons. So we're just gonna insert this value, 180 cos of alpha is equals to 164 dividing both sides by 180, and this gets cancelled out. So we have cos alpha is equals to 164 by 180. Now to find the value of alpha, we're just gonna take cos inverse of 164 by 180 and we're gonna get the value of alpha, which is going to be 20 which is going to be 24.3 degrees to 1 decimal place. So there you have it. Your value of alpha is 24.3 degrees.